If you've seen this Tesla coil at my science fair, you know all it does is really lights up fluorescent bulbs. Today, I'm going to show you how to make a much better Tesla coil that can do this. And make other bulbs do cool things as well. So I just received a new Tesla coil and sanded off the end so I could connect it to, and I'm powering up with a Slayer exciter circuit. This is my old Tesla coil. And look how much imperfections it has. This is a lot better. I'm just about to wind the secondary, which I'm thinking on using this wire for. I'm probably going to do 3 turns, as that will probably give an efficient voltage for the Slayer exciter. So I'm just going to start wrapping wire around this. So 1, 2, 3. Okay, I'm going to cut it here. So now I have to strip the wire. And the other one. So now I have to design something to keep it unsafe, because this is stranded and flexible wire. This is the copper wire I was going to use, but I don't have enough of it. It would only make 1 turn, and that won't give a very good efficiency. So I'm going to find something like a larger pipe or a wood structure to wrap this around. I found something that fits over the Tesla coil to wrap it around. So all we have to do is just get this coated in duct tape and wrap some wire around it. These are the parts we cut off. I've added a primary. Got the Slayer exciter circuit working up with some power transistors, and I'm going to get some wire and start it up. Let's get a screw. So I'm going to start cranking up the power. Okay, now let me attach a sharp breakout point, like this screw. So we cut a piece of wood to use it as a base and glued down the Tesla coil. This is going to be used as the primary. I'm going to slip it over right there. Now I should tape the breadboard containing the circuit down to a good spot, like here. So duct taping this right here and adding the primary back in. So the switch, perfect. So the switch is good right there. This is the Slayer exciter circuit. It is used, if you've seen my science fair project, it uses that to make a weak Tesla coil that can only light up a few LEDs. This is the board for the science fair project. Wires for the primary and the 2 Slayer exciter circuits. This time it's only using 1 Slayer exciter circuit and 1 primary, but it has this power transistor that can dissipate much more power and provide much more power to the circuit. And that's how this modification can provide bigger arcs. Now I'm attaching an aluminum heatsink as a top load to act as a capacitor to the environment and increase the voltage. And now I just forgot to wire up the connection. I'm adding the breakout point, which reduces the voltage needed to make a certain length of an arc, producing a longer and cooler arcs. But well, they're not really cooler because they're actually very hot. I have the coil all wired up and I'm connecting it to my lab vent's power supply. When you first power the circuit up, they produce these sort of arcs that are extremely hot. Ooh, maybe I can make like a mini Jacob's ladder. Oh, cool. It's a Jacob's ladder. A Jacob's ladder is where you have 2 wires. The arc will jump over the shortest point, and because the arc is extremely hot, it will start heating up whatever's above it. When plasma takes a path through air, it prefers hotter air and more humid air. That produces an effect that makes the arc keep rising because the air above it is more conductive. And that keeps rising until it hits the top, where it's too low of a voltage to jump across the top, and returns back to the bottom. So, that's how I made this Tesla coil. That produces pretty nice arcs and shoots plasma from it. So, sorry I haven't made any videos in a while, but there's a lot of things that have been distracting me. The Tesla coil didn't arrive for a while. Also, I was going to do a video about supercapacitors, but they never arrived. Also, due to some recent problems we've been having with Amazon, the next few videos will not be coming out every week. Also, when I was testing out my Tesla coil, I powered it up and the top load fell down and it ripped the wire out. I powered it up again and it started making a Lichtenberg fractal inside the PVC pipe. I'm going to have to cut it down to this length so that I can still use it. So yeah, that's what's going on. Thanks for watching.